Good day to Encik Maslan and my fellow friends. I'm Chong.
And I'm Leong.
And I am Ilya Akila.
And I'm Muhammad Nur Shukri.
In this video, we are going to discuss and present Lab 3, which is Human-Machine Interface System that contain two tasks. Leong may begin task.
Okay, so by referring to task 1, the system operation sequence state that the system will be a self-holding circuit for this start stop push button as usual, and then a 3 station with 3 different sensor and also 3 different outputs of the cylinder. So by referring to this operation sequence that when each of the sensor detected the object, so the conveyor will be stopped for 3 seconds, and then the cylinder will be extend. Okay, for stamping process they will extend. Okay, after that, for once we assume that the cylinder will be extend for only 1 second, since we have set the conveyor to 3 seconds, so which means there's 2 seconds remain for the cylinder to retract back. So for station 2 and 3, there's almost the same, which one is for inductive and one is for capacitive, which is metal and also plastic object. So at these stations, when the sensor is detected the object, okay, so the conveyor will be stopped for 3 seconds, and then the cylinder will be extend to push the object, and the object will away from the conveyor and then drop into the respective box. Okay.
Right.
So by referring to the CX programmer, we didn't use the differential up or differential down as when the either one of the sensor detected, okay, then it will open up the round 8, so which means the conveyor will be stopped until that the timer reach 30 count, which means it's 3 seconds. So it will close back the circuit and let the conveyor run. So because I didn't use the differential, is when the conveyor is stopped, okay, the object is detected. So after 3 seconds, when the conveyor is start back, the object should be moved away from the sensor. So the sensor will be open and then will be reset the timer. Okay. Okay, so for round 1, 2, 3, 4, 5, 6, okay, it's almost the same, which means one sensor and also one output. We labeled as real output, which is 100.01, 02, and 03. Okay.
All right.
So this is our HMI, which is CX designer. Yeah. So as usual, this is the main control, which is similar to we can call as a self-holding circuits, and this is the stations that we simulate. So this is station 1. By referring to this, station 1 is stamping and photoelectric sensor. Okay, station 2 and station 3 will be inductive and also capacitive sensor, and also will be a electropneumatic cylinder X and Y. Yeah. So we use this icon to
present.
Yeah, to present that this is the pneumatic cylinder, similar to this stamping process. So now let's start this system. Okay, so we press start button. Okay, so the system will be run. Conveyor will be run. Yeah. Okay. So now we simulate it. Okay, as station 1. Okay, when it detected object. Okay, so stamping process will be extend for 1 second and then retract. So now conveyor will run back after 3 second count. So at this moment, that the object should be moved away, and so this electric sensor will be no detect. So same goes to inductive sensor. Okay, you can refer here. 3 second count. Okay, so conveyor will be run back. So okay, so for the last one is capacitive. So you can see at this one, so I press. Okay, so only 1 second. After 1 second, then it gives this electropneumatic to retract back before the conveyor start run. Okay, so and the operation is repeat until stop button is pressed. So last we press stop button. So everything will be stopped, even though there's a sensor detected. So it will still remain, everything is be off conditions.
Okay.
Okay, so any question for this task 1?
No, it's okay.
It's clear, right?
Seems to be good.
Yeah.
Yeah. Okay.
Yeah.
By referring to task 1, there's a note that it's highly recommended to add extra that to count for the metal and non-metal object of X and Y, and also to display the counter. Okay, so refer to our ladder diagram. We use reversible counter, which has an increment and decrement input and also a reset port. So since we only require the increment, so we just connect the increment and the decrement. We're using a working bit that is not using. So for the inductive and also capacitive sensor, okay, we have two reversible counter that shows on HMI. Okay, so let's start. Okay, so when inductive sensor is detected, okay, so object X
Count
count
one.
is 1. Yeah,
And
to
2.
increase to count 2. So same goes to capacitive sensor. Okay, conveyor runs. Okay,
1 second.
pass.
1 second.
Yeah. Okay, so when we stop, since there's not required a reset button, so I connect directly to the stop push button, which means when we press stop, okay, it will reset back to 0. So if user want to view to view the object total count when the system is stopped, so users can request to add a reset push button. So then we switch back this stop button to reset push button, which require one more real input of the push button. So which means that user need to reset, then only this count will be reset. And yet we set it to maximum count with 9999. So now let's move to task 2, yeah?
Yeah.
Okay, so open up this file. Okay, so close this. Task 2. Okay, so task 2 will be a bit simpler.
Just process up and down.
So try to. Okay, so for this,
Wow.
okay, because I found similar things that I can use to yeah, so this simulate the real watt. So inlet out the watt, and this is the tank, and yeah, usually high level sensor, low level sensor, we're using the shutter. Okay, so now let's start. Okay. Yeah. Okay. So based on the task 2, okay, start button press. Okay, this also as usual, which means scaffolding. This is a must lah for every circuit. So it will be a
Yeah.
start stop. Okay. Okay, so liquid level tank is low. Then when low detected, then inlet valve will be on and outlet valve will be off. So
Yes.
to fill the tank up. Till high level detected, then only outlet will be on, inlet will be off, and the process will keep repeat until we press stop button. Okay, so as you can see that I had used a one keep holding bit, keep bit. This keep bit, which means that when the system is off, which means there's no power supply, and then when the power is come back, okay, it will still remain, which means that okay, because maybe we are at the condition that inlet valve is closed and outlet valve is open, which means let the water out. Then suddenly the current out. So when the current return back, it will remain that this is the process that outlet valve is still open, inlet valve will be still closing. This is a keep bit. So this keep bit is 1 or 0. Okay.
Okay.
Okay. So I start. So start.
Inlet.
Low detect. No. Okay. Low detect. High detect. Okay. So you can see that why is it that this low level sensor I will be using one as output. Okay, so which means that when this low level sensor when the water is lower than this low level sensor, so this low level sensor will be no detect. So not assume we use it as same as the high level sensor. We don't want to get two different sensor. We use same sensor, which means that okay, when it detect the water above the sensor, okay, then it will send a one high signal to the controller. So you can get it?
Yes.
So which mean now when this low level sensor is 0, which means that the
The high
water
level.
inside the tank is lower than this low level sensor. It's maybe around here. Okay.
Okay.
So until the water above this low level sensor, so okay, for example, it's till half or what, so this will be
On.
give 1. Okay, so you can see I will give 1. Okay, and then you will fill up till high level sensor detected. Okay, so when it detect, we also send high signal. Okay, so it will keep the beat. Okay,
Okay.
and then the water will be dropped. Okay, when the water drop, high level will be 0, and drop until below the low level sensor.
Send 1.
Yeah. So okay, we will repeat and repeat
Okay.
till you press stop button. So okay, start back. Okay, this is inlet. Okay, for example, that reach up now, maybe around here. Okay, like that. That's okay. This which means that the water is at the half, it's going down, but then it's not reached to the low level sensor. So I press stop, or when the system is no power, and then we power back, and then we start again. It will still remain that the water will be going out until the tank will be empty. If you keep the process, which means that the water is flowing out from the tank, then it will keep flowing out from the tank. Which means that okay, no
Continue
power,
back from the previous.
you remain at the previous condition, will not be reset. So that's why I use a keep bit.
Oh.
Okay, yeah. So this keep bit, which means that when there's a
Yeah.
power shortage, yeah, it's like
Memories.
memory, yeah, storage, yeah, yeah. Okay,
Okay.
so I think this task 2 will be more easier to understand, right? Because that you can see that that's not so complicated.
Yes.
Okay. Yeah. So any questions?
No. Seems to be good.
Sure. Okay.
Okay, I should. Okay,
Okay.
understand. It's clear.
Me too.
Okay.
Understand.
Yeah. Okay. So this is finish of our lab 3. Yeah.
Yeah.
Yes.
Okay. So that's all.
That's all for lab 3. Thank you.
Thank you.
Thank you.
Okay.